Thank you. Yes, um, so I'm going to be talking about some work that I've been doing for IOHK on Cardano node, and that is getting what we call the chairman test, which is a integration test that we do to ensure that our nodes can run in a testnet and be able to communicate with each other properly. And the setup looks like this. This test already existed, but I was asked to write a version of this test that doesn't rely on a bunch of scripts and some Nix expressions to drive it. So we wanted something that was in Haskell so that um, like people who aren't familiar with the infrastructure that's used to run the existing code can easily run it locally, and also to be able to run this on other platforms like macOS and Windows. And Windows in particular means that Nix is not an option. Like you can run the test in Windows, like for emulated Windows via Wine, but that's not actually supported by by other teams that maintain our networking layer. So to be able to run it legitimately on Windows is quite important. And yeah, so that's another reason why a pure Haskell version of this is desirable. So yeah, so cross-platform was like something that's important. To be able to run it in Nix regardless. Like to be able to run it with just Cabal is nice, but also to be able to run it in Nix as well. So we can preserve the existing behavior of being able to run it in our hybrid build servers. Being able to debug is important. So to be able to debug it locally and in CI. And in CI, it's a particular challenge because I think of it like as a kind of pinhole programming. Like you have CI system and then whatever information that it reports when it runs and then fails is all that you get. So to be able to have like something like logging, but something that's like sufficiently like sufficiently to have something that's sufficiently verbose, but also easy to use that we can find problems in a failed integration test. And then also like test isolation. So when you run multiple tests, because it's going to be happening in CI, and it may not necessarily be the case that there's proper like isolation. For example, like if you're running a network that might get port collision and that kind of stuff. So isolation is good. The nice thing about the existing system, the previous system, was it ran the test in Docker, which meant that you got more isolation than if you just ran it in pure Haskell code. Because in that case, you're just in one machine, you're sharing like all the same ports. Okay, so I'll just show you the end result to start with, just to show to be able to see. Oh, it's actually still running. But this is like an output of a failed test that I forced it to fail intentionally. At the end, I added. Oh, you can't see here. Yeah. So at the end, I added like a failure at the very end of the test to force the failure. And if when you force the failure, then in Hedgehog, you get the source code of your test with annotations in like this. And this had turned out to be really, really useful, in particular for that kind of pinhole programming kind of thing, where when you're in CI and it fails, all the information that you want to be able to debug that has to be there. And because I am intending to rely on annotations, I found it useful to have some additional functions to help me be able to do this kind of thing. but the script, I'm scrolling too fast probably, but the script generally has this kind of structure, like create a temporary workspace, which is a temporary directory that it puts the files, its working files into. It sets up some configuration, and then here it's annotating all of them, so you can see what kind of configurations it's using. And then creating directories for each of the nodes here, and then later on, yeah, just heaps and heaps of configuration. You can see why like this is really important to make this information visible, is because if something goes wrong, then it could be just like a tiny configuration detail somewhere, and if you can't see it because it's on the CI machine, you can't just say, oh, I'm going to open some files, some configuration files, and figure out what the problem is. Like literally you get one shot and then you need all the information you can get. Yeah, so then it creates keys and addresses and that kind of stuff. So there's lots of things that's happening. The details probably not that important. Then later on, a lot further on. Yeah, so by the way, all these commands here, it's using a CLI tool, it's Cardano CLI to do the work. So that involves like execing Cardano CLI, and then finally bringing up the testnet here. No, actually, it's still not. That's just creating more keys. Back down, it's more addresses. Yeah, it's just one giant thing. Here we go. So this is creating the testnet there. Like like in here, you could see that I'm doing an exec on the CLI, and then you can see all the arguments that are passed in. And then further down, yeah, still doing more CLI, sorry. Okay, here's where the nodes are actually created. So it starts nodes, says that all the log files go into these locations, and then here creates the process. And you can see what command line arguments are used there, and what ports are used. And then it runs this chairman process at the end, which is this one. Here, I think it's this. No, oh, actually, here I'm doing some assertions. So I'm asserting that like by a certain deadline, like it opens a port, and then later on by a certain deadline, a log line appears in the log file. And then later on, I run the chairman, which is take the first node and then connect to it. And so it runs the chairman process here. And what the chairman process does is it connects to the socket and it does some things, and then asserts that certain things happens. And if it's good, then it exits with a 0 exit code, which means success. And if it fails, then I would like to see what the chairman printed out. In this case, there's no problem because it was an artificial failure. But yeah, so the idea that I had was I wanted to use Hedgehog to make this information become available in the event of failure, so it's a lot easier to debug. And it turns out that while I was trying to do that, there are a couple of challenges that led me to write kind of some library code that I thought might be useful in a wider context. So here's the list of things that I ended up covering. So first one, more annotations. Like you can see, the general idea is to, whenever there's something useful, we want it to be annotated. If there's something that happens in the loop, that's okay, because the annotations just like get appended like that. And so as part of that, I felt like there were some things that would be nice. Like, so Hedgehog has an annotation function, which does what I want, except sometimes I want to be able to, let's go to the beginning. Do something like this. Like, so this is basically what the annotation function does. It annotates at that point. But then there's other instances where like I do some kind of computation and then I want to annotate it, but I want to keep the values. So having something like that in Hedgehog would be nice. I can kind of do that both in one shot rather than doing a let and then doing the annotation. Another thing is, well, I'll go through this. So be able to note and show at the same time, or to be able to just note a string. To like some computation here, if I'm generating like a random port, for example, then I can annotate that and then store the port. Let's see. So that kind of stuff. So I would have in base a bunch of functions that look like this, like that. And then some other issues that cropped up. And I've got some tests to demonstrate this. So here, I'll need to be able to run these tests. So I'll bring this up. Here. And this is related to sometimes the annotations not showing up because an exception has happened. And then like all your hard work goes down the drain because like you put those annotations there and you don't get the you don't get to see them. So this first one is like what we expect. You annotate something and then we fail. You see what's being annotated. But then later on, that's fine. Oh yeah, this is a kind of thing that I used to do before I started on this project. Was like if I computed something and I wanted to be annotated and then I wanted to keep its value, I just do this. But I think it deserves its own like function, which is why I introduced the note stuff. But then later on here, okay, so here's a few examples of me doing annotations with like strings. If I follow the conventions, if you have an underscore, it means I don't care about the return value. And then here, I'm doing some IO, and then I want to keep the value, but also show it. And then the difference between IO and M is IO is like just if I want to run some IO, but M would be like in my test monad. So I've already lifted it into the test monad with this function here. And then this does the iteration. Okay, so with the exceptions, I'd need to enable the first. Okay. Here we go. Oh, I should clear. Okay. So this first failure here, you could already see there's a problem because here I've added an annotation and I'm reading a file that doesn't exist, so it's going to throw an exception. But I don't get to see the annotation at all. So I could have like this huge file and I've annotated a lot of things, and then it comes to a certain point and it fails, and then I get no information. I don't know what line it happened on. I don't know, like maybe the file name that I've constructed is wrong, and I annotated it to see what it was, but I can't see it because this happened, right? And the way to work around this is to use the Hedgehog eval IO function. So what that does is it runs the IO action and then it catches the exception. And then because the eval IO has access to the call stack, it can then work out like where in the test that it failed and kind of be able to put the annotations in place for you. So without that, Hedgehog won't be able to do it. But it's not foolproof because here I have another example that uses like unsafe interleave IO to force it to be lazy. So the exception doesn't happen straight away. It kind of, I get this thunk back that's not evaluated. And then here I do this comparison. And then it's just lucky in this case that it worked. So here, I get an exception, but I still get to keep my annotation. So that's nice. But then if I go to the next version here, this one, I'm not using this operator anymore. I'm just manually doing it myself. I'm like calling unless, which then evaluates this Boolean expression. But then by evaluating a Boolean expression, it evaluates the thunk and then throws the exception. But Hedgehog doesn't know about this. Whereas here, because it's inside this operator, it can catch it, but now it's like outside, so it can't catch the exception. And so if you do any kind of manipulation of pure data structures and it causes an exception, like it's game over. You don't get to see, like if you had this in CI, it's like now what should I do? And I had no idea. So that's the kind of thing that the problem that I experienced, and it kind of like sometimes I run it in CI, I don't get the information, but I'm not quite sure why. But like eventually it worked out that it was because I'm doing this kind of thing, and I need to avoid that as much as possible. And then there's also this other problem here, which is like I call it an island annotation, right? So I have this via function, which is at the top of the file, and it does an annotation inside it and then returns it. So it's really simple. But the problem is, like, the moment you do that, the annotation doesn't appear in place anymore. It fails here, and the annotation, like I want it to be here because that allows me to contextualize it. But then I'll just get this like outside here. And if I call via multiple times, I don't know which one it corresponds to. So this is less useful. So we need to be able to avoid that. Yeah, so that can be avoided with like using like with frozen call stack to freeze the call stack, so you don't like descend down the call stack and get a call stack that points somewhere else that causes this. Yeah, so that was another problem that needed to be solved. And then Workspaces, which is this one. I mentioned this earlier at the beginning of the test, to be able to say I want to generate like a temporary directory that starts off empty. Then that passes me the temporary directory that I could work with, and I can generate all my temporary directory files into there, all my config files. So that's really helpful, especially like if I'm running this test concurrently, then I don't want them to interfere. I think I covered, defectful assertions. Yeah, maybe not. So combinators, I think that are useful to include in Hedgehog, maybe like assert IO, because be able to, be nice to be able to like run some IO and then assert that it's successful. Deadline assertions, which I mentioned earlier, which is to run an assertion multiple times until you hit the deadline. And if before the deadline your action reevaluates to true, then you succeed. If not, then you time out, and that's a failure. Now, with this, sometimes, like, because in this case, I'm waiting for a port to open, but if it doesn't open, it might be helpful to look at the logs. But if the logs aren't visible because you haven't annotated it, then you'd have trouble finding out why it failed. So then here would the idea would be to, if it failed, to then annotate the logs. And I had I raised a ticket here on Hedgehog. Something that I think would be useful is if a test fails, if there was some way to add a hook to add some additional action to run, and that would let me do the annotation on failure. And so that would be useful. If I can't actually annotate the file before failure because the file's still growing, and if I need to wait until the failure happens, and then only then will the full log file exist for me to actually log. If I log too early, then I don't get the full log file, so that's not good. And then, yeah, so I raised a ticket for this, and it was mentioned that maybe I ought to be able to catch an exception because that's how Hedgehog communicates failures. So that's something that I need to investigate. There's an aborted STM experiment. So this was a curious thing that I tried, which ended up not working. Something that I wanted to do was to create a TVAR, an STM TVAR, and then when the test fails, to annotate with the initial value of the TVAR as well as the end value. So this is one of those on failure, please do this. And I implemented it using unsave into leave IO, which makes that allows me to like capture the value at the very end, and then even though I annotate it right at the beginning, to capture the value at the very end. Unfortunately, it looks like the GHC runtime uses STMs as well. And if I do it inside an unsafe into leave IO, it actually is not safe, because then in that case, you get an STM inside an STM, and that triggers an exception. So that's no good. And I have in this issue, in this PR here, a link to that atomically was nested thing. So I had no idea this was a thing, but so now I know that it's actually not safe to do this kind of thing. So there's that. And then resource cleanup. If I'm spawning processes, then I should make sure that they die at the end of it. I don't want things to keep running. So there was, where is it? Yeah, so I have a resource T in my stack, and then I have to do some hoisting to get that to work. So there was that. And then I forget what that's in reference to. Oh, right. So following the philosophy of annotating everything, it would be nice if it was automatic when I use some IO functions that it would annotate stuff for me. Like if I did in here, if I had done, say, h.eval IO and then IO write file, that doesn't compile, but like, I think you get the idea. It'll write to the file, but then I haven't recorded anywhere what that file was, and it doesn't get annotated. So I wrapped, essentially created my own version of write file that annotates the file names when I use them, so I don't have to think about doing them all the time and forget about doing it. So following the philosophy of trying to annotate as much as possible, having wrapper functions for a lot of the IO functions that do the annotation automatically is quite useful. And then let's see. launching executables with the right binary. So initially I was calling Cabal exec or Cabal run to do it. Turns out to be not a good idea because Cabal itself pollutes the output. So it's, like it'll add extra stuff into standard output, and then when you do your assertions or whatever you do, that depends on the output. It may not work properly. But the other reason it's also not a good idea is because if I'm working with file descriptors and I want my child process to inherit them, going via Cabal is not a good idea. You want to execute the thing directly. So the approach I went with that was to parse the plan.json that you get when you compile with Cabal to find the executable. And then there's a fallback to use an environment variable for that. And then some fun hurdles, like I have to start the process in temporary directory so that things will work properly. That's so that it can find all the configuration files. That kind of affected how I start the process. But there's the code for handling all of that kind of stuff. And then there's lots of details. I think maybe it's not worth going into, but like operating system restrictions means that writing cross-platform stuff is just really, really awful. But yeah, that was part of the work. So yeah, that's my my talk. Any questions?
Are you publishing Hedgehog-extras soon?
Oh, well, no, I'm not publishing it yet. I just wanted to know like what people thought of the idea. And it felt like to me some of the stuff maybe belongs in Hedgehog itself. Like there's definitely stuff there that doesn't belong in Hedgehog, but be good to identify what people think would be good things to push to Hedgehog. And the extras library is in Cardano node as a separate thing, but it is like completely generic at the moment. I think it needs cleanup, but it can be broken into a separate library. So
oh, it's called like that. I didn't.
Yeah,
I thought I would come up with a name.
yeah. So it's called like yeah. I hate to write code that's like non-generic if it's possible to make it generic. So I ended up doing that. At the moment it's sitting there. It seems out of place. But yeah, I pulled it out also. Like if it was kind of intertwined with this, then I wouldn't be able to use it in other like projects at IOHK, and I'm pretty much interested in reusing it too. So yeah, that's the idea.
I think it would be nice having it published as a separate library because it can evolve at a faster rate than Hedgehog itself does.
Oh, right.
Yeah, because from experience, looking like pushing changes to Hedgehog can be quite time consuming, and you push something in there and then you notice that there is a better version or you want more, something like that. Maybe it's better to just have it as a library, let people experience it, iterate on it, and then maybe Hedgehog starts like absorbing some of it as well.
Okay. Yeah, I could certainly.
I would use that.
Yeah.
Some of it. Yeah.
Yeah. Yeah. So I could put it out as a library, and then like the API is probably quite raw at the moment, but I guess it can evolve, and that's fine.
Mm-hmm. And another thing, I don't know, I never looked. There is a difference between eval.io and lift.io here, and I understand why they work differently. But why can it be made that lift.io for that specific property T or whatever it is just does eval.io internally, or it wouldn't be proper behavior?
I don't know the answer to that question.
I mean, there must be a difference. That there must be a reason why these two exist differently. and it wasn't done like that. It'd be interesting to know why.
Yeah. Yeah, that's probably a question worth asking. Maybe a thing to do would be to raise a ticket on Hedgehog and ask the question. Yeah.
Yeah, so publish.
Okay.
Thanks.
Thank you.